Hello students, welcome back. Let us resume our discussion in section 1, and this time we will complete it. We have two more here, complementary identities and supplementary identities. Pi over 2 minus theta, pi minus theta, and we went through a lot of identities already. Symmetry identities, rotation identities 1 and 2. And what we are going to do here is to use these previous identities to prove the complement identities and the supplement identities. So this time, we're not going to use those pictures, those circle diagrams. Instead, we're going to use previously proven formulas. Okay, all right. Sine pi over 2 minus theta, and then somehow you have to work it out, and then we have to prove this is cosine of theta, and your job is to fill in the middle part. How'd you do that? Let's see, we already have rotation identity here. As a matter of fact, looks like we can use this and that. Sine of negative of theta minus pi over 2. All right, and then if I use the symmetry identity, this will be negative of sine, so negative of sine of whatever that was inside, and then sine of theta minus pi over 2 is negative cosine. We are almost there. Double negative, so it's cosine of theta. Is this the most effective way to do it? I'm not so sure, but it works. And then you can do something similar to prove for cosine, and do the same for tangent. And by the way, I just thought of another way. So you can consider this is negative theta plus pi over 2. So sine of pi over 2 minus theta. So negative theta plus pi over 2. So we'll use this. So cosine of negative theta. Is it confusing? Okay, this way it's going to be less confusing. So we express it like this and use this one. So cosine of whatever the angle, and cosine of negative theta is just cosine of theta. So it looks like there's another proof. But in any case, remember, we combine the rotation identity by pi over 2 and the symmetry identity. How about the others? Well, stop the playback and go ahead. All right. Okay, that was sine. And then as for cosine, let's see. Cosine negative theta plus pi over 2. So plus pi over 2 for cosine, yeah, right here. Negative of sine, so negative of whatever the angle, sine of negative theta. And then if I use now symmetry identity, sine of negative theta is negative sine of theta. Take another negative out. We have sine. And then something similar for tangent. By the way, for acute angles, we already went through these, by the way. We can work out a triangle like this. If the alpha is the angle you have, beta is 90 degree minus alpha, or pi over 2 minus alpha, complementary angle, and opposite of alpha is adjacent of beta. Opposite of beta is adjacent of alpha. So you're going to get sin of alpha and cosine of beta are the same. And cosine of alpha and sine of beta are the same. And then let's see, opposite over adjacent versus adjacent over opposites. So tangent and cotangent will also flip-flop. But this idea works for acute triangle. So for acute angles, so that we can embed into a right triangle. But if you have a general angle, then the right triangle method does not work anymore, and you have to use some other method. And among other methods, well, combining the rotation identities number 2, rotation by pi over 2, and then symmetry identity, and that method worked out okay. Alright, we'll say we completed 1.8. Now let's go ahead and do 1.9, supplementary identities, pi minus the angle. So this time, I don't think we are going to need rotation identity by pi over 2 rotation or complementary angles. So let's combine these two, symmetry identities and rotation identities. For example, the most important of the bunch, sine of pi minus theta. How will that work? I can rewrite it as negative theta plus pi, and that's negative of sine of negative theta. Because any angle plus pi, we get negative sine. So previously we had negative theta there. And then we apply the symmetry identity. Then what do we get? Another negative, we have sine of theta back. Another way, sine of pi minus theta is sine of negative of theta minus pi. So that's negative sine of theta minus pi, because of this symmetry identity I can take the negative out, and then minus pi will get negative sine, so negative of another negative sign, so we have positive sign. Well, there can be multiple ways to prove, and you can do the same thing to cosine and tangent functions. Stop the playback and try on your own. Did you get all those? Let's see. Oh, the reciprocals follow immediately from the original, so I don't think that's really important. Okay, all right. Okay, sine of pi minus theta, and then let's take pi away, then negative theta remains, and then because of this we have negative. Likewise, subtract pi away, then cosine becomes negative cosine, and then cosine of negative theta stays as cosine of theta, so the first negative does not go away. We get negative cosine. As for tangent pi minus theta, well, take away pi, we have to have same tangent, so tangent of negative theta. Tangent is odd function. I can take the negative out, so we get negative tangent. So by combining the rotation identities and symmetry identities, we can prove everything for supplementary angles. But in the end, if you have a list of all these, they are mighty confusing. So what is the best way to handle it? Now remember this. Symmetry identities, remember these because these are coming straight forward from the graphs. Sine and tangent are odd functions. Graph those and you'll see symmetric with respect to the origin. Cosine is even function, so remember symmetry identities. And as for the others, key point is whether you're pi or pi over 2. Plus or minus pi or subtract from pi, sine stays as sine, cosine stays as cosine, tangent stays as tangent all the time. Pluses and minuses, well, figure those out individually. And then plus or minus pi over 2 or pi over 2 minus, whenever you have pi over 2 involved, sine becomes cosine, cosine becomes sine, tangent becomes cotangent, cotangent becomes tangent, and then secant becomes cosecant, cosecant becomes secant. Basically, trig functions become cotrig function and vice versa. That's what this pi over 2 is doing. Plus or minus, you'll have to figure those out individually. For example, let's suppose that you're facing this kind of problem and you're confused. Theta minus pi over 2. Is it positive sign or negative sign? I don't remember. I just remember cosine becomes sine because this is plus or minus pi over 2. Okay, alright. Cosine of anything. Oops, sorry about that. Pi over 6 minus pi over 2 minus sine of pi over 6. Okay, what's this value? If they're same, I'm gonna get 0. Yeah, they're same, I got 0. And then if negative, this will be 0. It's not 0, so it was the other. For example, in this case, this will become 0. So use your calculator. Cosine minus your target, are they the same? Just calculate once, and if you get 0, then okay, that's it. In my opinion, that's the best way to figure out pluses and minuses. Just remember, sine becomes cosine, cosine becomes sine, and so on for pi over 2. Sine remains sine, cosine remains at cosine, everything stays the same, except for pluses and minuses when you have just pi. And then figure out pluses and minuses through calculator. That's my suggestion. Okay, alright, that completes the proof of all the trig identities necessary for now. And there are going to be a bunch more in the next lesson, but for now, we are done with the proofs. In section 2 and section 3, we're going to do a bunch of application problems.